Hi and welcome back to WySLICE. In the previous activity we have seen Conway's game of life and played around a little bit with it and have seen that, well, there are all these patterns and there are these relatively simple rules that determine how a pattern is transformed from one iteration into the next iteration, and based on this we have seen that things move around and maybe they die out and maybe they move to different parts of the screen, etc., etc. Now, let's study this in a more principled manner. Let's say that we are scientists and we now want to investigate this game of life. And this would be similar to how you might study any new system, whether that's a system in nature. For example, I see lightning and I want to know what causes lightning. I can run various experiments to evaluate this, but also in our context here, how you might evaluate a computer system or a particular piece of hardware, like the microbits that you guys have access to, and see how it behaves in practice. New programming language, a particular game that I might be playing, or something that I want to create using a computer, a new program that I'm not familiar with. And a great way to do that is to essentially just play around with this, which we have done in the previous activity, but now we're going to do this in a more principled manner, in particular using the scientific approach of coming up with hypotheses and then evaluating these experimentally to see whether they are true or not. Based on that, we can revise our beliefs on how the particular thing, the system that we're studying, works, and then try something different. Okay, so in our context here for the game of life, let's say, I will go back to the browser here. Let's say that we want to achieve is to find a pattern that does something that's interesting. And this could be running for a large number of iterations where we have non-boring changes. That is, we don't want these kinds of oscillating patterns that we have seen before because, well, not particularly interesting, right? Or maybe we want something that grows really, really quickly. So something that creates more and more live cells. Okay. So how might we go about this? Well, we're going to come up with a hypothesis and we're going to test this. I'm going to come up with a very simple hypothesis here. My hypothesis is that this particular pattern will result in something that's really, really interesting. Okay, let me try this. Start. Okay, nothing happens. Well, clearly my hypothesis was wrong. So let me reset this and revise my hypothesis and say that, well, I'm gonna add these things here, and then I'm gonna hope that, oops, not this one, yeah, and then I'm gonna hope that something interesting and exciting happens. Okay, let's start. Ooh, that looks better. Oh, okay. Well, that didn't really work out either. Okay, let me try this again. I'm going to add some more pixels here. So I'm continually coming up with new hypotheses based on the results that I have observed when I tested my previous hypothesis. Hopefully, let's try this. Well, that wasn't much more interesting either. Eventually, I will get there. Let me try one more thing here. And then, okay, start. Well, that is actually quite a bit more interesting. This is now moving. It's still moving. Ooh, I have to zoom out now to see what's happening here. I would say that's pretty successful so far. It hasn't run for a whole lot of iterations, but that's at least much more exciting than what I had previously. I'm going to stop this here. And what I want you to investigate now is exactly this. Can you come up with a starting pattern that is interesting in the sense that even after a large number of iterations, it still does interesting things. So not just oscillate between kind of two different stable states or completely die out or end up in a stable state where nothing changes anymore. And while you're doing this, try to figure out whether there are particular characteristics about the patterns that you start with that enable this, to kind of tackle this in a more principled manner. So is it, for example, the shapes that you start with? We saw that the kind of rectangular shape or the quadratic shape that I started with didn't really do anything, but maybe if you scale it up, maybe if it's not filled, will that maybe do something? Or is it more related to the number of pixels that are alive to start with? We have certainly seen in the experiments that I have run that as I add more pixels, more and more exciting things happen, right? In particular, during my last hypothesis, where I had a really quite large pattern, and that did seem to do something interesting. So maybe there's something there. Try to find out what is it about the particular pattern that makes it successful or unsuccessful according to the things that I've mentioned earlier. And of course, feel free to come up with your own criteria. Maybe you want a pattern that doesn't grow as much, but kind of, stays in a particular area, so it's easier to observe and then creates very nice and symmetrical patterns. That might be also something to aspire to. So have a go at this. Play around with this and see what you can come up with.